And so we know it takes energy to turn something from a liquid to a gas. We can quantify that and find out the exact amount of energy. And this is called the enthalpy of vaporization. It gets delta H VAP for vaporization. And of course, it's the energy required to vaporize 1 mole at the normal boiling point. And in general, the stronger your intermolecular forces, the more energy that's going to take. And so it's going to have a larger delta H of vaporization. So stronger IMF is equal to a higher delta H of vaporization. Water, for example, with its very strong intermolecular forces, in order to get a mole of water liquid into the gas form, your delta H of vaporization here is going to be equal to 40.7 kilojoules. And so, of course, we can do kind of questions, math-based questions on this. How much energy to vaporize 10.0 grams of water at its boiling point? So we would start off with the 10.0 grams of water. We know that our delta H of vaporization is talking about per mole. So we have grams. We can go to moles for that using the molar mass, 18.02 grams per mole for water. And then we know for every 1 mole of water, it takes 40.7 kilojoules. Do the math there, you get about 22.6 kilojoules of energy to essentially turn 10 grams of water at the boiling point to 10 grams of steam. Note that like kind of vaporization and condensation are opposites of one another. And so the delta H of condensation is the same as the delta H of vaporization, just the sign is opposite. So this is negative 40.7 kilojoules. Know what that means, though? It means that condensation is an exothermic process. Which kind of might be a little bit hard to wrap your mind about it, but around it. But if you think, kind of about it correctly, it does make sense, right? So to boil something, you have to put energy into it. That's an endothermic process. And when it condenses back down, it's going to release energy. That's an exothermic process.